Okay, starting the next unit here, Unit 6, Lesson number 1. On occasion, we need to be able to take an algebraic expression and change it in terms of a trigonometric function. This is quite true in calculus if we're trying to do an integration, and algebraically we are stuck. But if we switch it to trigonometry, we're like, hey, we've got a thing to do. We can do this. Notice theta is between 0 and pi over 2. In other words, theta must be an acute angle. That's good news because on a right triangle, there is the one right angle and there are two acute angles. And this is very much like if you're working with a jigsaw puzzle. When you start out, you don't know where every piece goes, right? But you know somehow you've got to get those pieces to fit together. Same thing. We don't have a general recipe or an algorithm you can just follow every time. Each time it's problem solving, you gotta try to figure out where the pieces fit. So for our first one, let's say we've got the square root of x squared plus 16. That's a wonderful algebraic expression. But what if I want to change it in terms of theta with trigonometry? Well, favorite things to draw in trigonometry, right triangles, right? I either want to draw a right triangle or I want to draw the unit circle. Most time it's a right triangle. Of course, if I select one of my angles for theta, fits in there nicely because it's got to be an acute angle, right? That was one of our constraints, that theta has to be between greater than 0 but less than pi over 2. And of course, by placing theta, I now know which side is opposite, what side is adjacent. Of course, hypotenuse was already predetermined. Hypotenuse must always be across from the right angle. Now, why did I put the square root of x squared plus 16 for the hypotenuse? We don't automatically put it there every time. What made me make that decision? Well, think about the Pythagorean theorem. A squared plus b squared equals c squared. That means c would be the square root of a squared plus b squared. So that's my clue that I'm looking at the hypotenuse. Because I've got x squared, and then of course 16 is really 4 squared, and they're being added together inside that square root symbol. Now, why did I put x for opposite? Well, if a squared is x squared, a must be x. Why did I place 4 for adjacent? Well, if b squared is 16, b has to be 4. Notice the legs are interchangeable. I could have switched the positions of the x and the 4, and this still would have worked out. But I like to keep my variable in the numerator of a fraction, and so I usually want it as opposite. So which function should I pick? Why did I pick tangent? Tangent is opposite over adjacent. Right? I can't use the hypotenuse. I'm trying to rewrite that expression, that x squared plus 16 inside the square root symbol. So I have to use opposite and adjacent. Now again, I could have flipped the positions of the x and the 4, but I really did not want the tangent of theta to be 4 over x. I think it's a lot easier to solve for x when x is in the numerator. So sure enough, x is just 4 times tangent of theta. Now, let's go rewrite our expression. Instead of having an x squared, I have 4 times tangent of theta, quantity squared. Of course, that really means what? That I'm going to take 4 tangent theta, multiply it by 4 tangent theta. Of course, the 4 times 4 will give me 16. Tangent theta times tangent theta is tangent squared theta. I see a common factor of 16, so I'll factor that out. Of course, tangent squared theta plus 1 is secant squared theta. That's on your reference guide. If you've not memorized it yet, you should really maybe make yourself some flashcards and start committing some of this to memory. Square root of 16, of course, will give me 4. Square root of secant squared will give me secant theta. If you're wondering why I don't have to worry about a plus or minus situation when I'm taking the square root with a variable, remember we're constricting theta to be between 0 and pi over 2, so it's going to be an acute angle. And if you think about unit circle, everything in quadrant number 1 is positive. Whether we're talking about sine, cosine, tangent, cosecant, secant, cotangent, right? X coordinate, Y coordinate, doesn't matter. Everything is positive in quadrant number 1. Hey, in this example, looks like there's a subtraction symbol instead of addition. So we're not looking at a hypotenuse. Right? I can place it as the opposite side. Again, if I think about the Pythagorean theorem, if I solve for A, I have to actually subtract. Right? When there's subtraction, we're actually solving for one of the legs, not the hypotenuse. Of course, X can now be my adjacent side, because if B squared equals X squared, B has to be X. 3 is my hypotenuse. If C squared equals 9, C must be 3. Now, which trig function is the triangle choosing for me? Well, I'm going to play with adjacent hypotenuse. It's got to be cosine. Can't use the opposite side because that's the expression I'm trying to rewrite. So I've got adjacent and I've got hypotenuse. Notice there's no choice that the 3 had to be the hypotenuse. Because of the 9 subtract x squared, that tells us the 9 is the hypotenuse squared. I could have flip-flopped the adjacent and opposite. If I had done that, instead of using cosine, I'd have to use sine. Of course, if I solve for x, 3 times cosine theta is x. So I can now actually start working on manipulating my original expression. Instead of 9 minus x squared, I'll have 9 minus the quantity, 3 cosine theta squared. All of that in that lovely square root symbol. Of course, I'll have to do 3 times 3 is 9. Cosine theta times cosine theta is cosine squared theta. Common factor of 9 leaves me 1 minus cosine squared theta. Of course, 1 minus cosine squared theta is sine squared theta. If you don't recognize that right away, remember that 1 can be substituted with cosine squared theta plus sine squared theta. The positive cosine squared theta and the negative cosine squared theta cancel out. Leaves me with sine squared theta. Of course, when I take the square root of 9, I'm just going to have 3. When I take the square root of sine squared theta, I'm just going to have sine theta. So I've rewritten my expression, square root of 9 minus x squared, as 3 times sine of theta. Reciprocals. What on earth is going to happen next? If you're getting good at this, you can now take a look and say, aha, I know what my hypotenuse has to be. Right, x squared minus 4, I can place that as my opposite side. Because again, I'm not looking at the hypotenuse. Right, if I solve for a leg, that's when the subtraction occurs. So my expression of the square root of x squared minus 4 has to be one of my legs. Of course, the hypotenuse is x. Because if c squared equals x squared, I know c has to equal x. So when I first saw the expression, I immediately decided, aha, my hypotenuse will be x, because x squared is the largest number because we're subtracting 4 from it. So x squared has to be the hypotenuse squared. Of course, adjacent side is 2 because 2 times 2 makes 4. Again, it looks like I'll be using secant. You're thinking, well, how come you didn't use cosine for adjacent hypotenuse? I don't want the x in the denominator. Right? I have to use adjacent and hypotenuse. And the first thought is always, hey, let's use cosine. But I really don't want x in the denominator. I want x in the numerator. It makes it much easier to solve for the variable. If I had started with cosine theta equals 2 over x, it would have taken me a little bit longer to simplify and come up with x equals 2 times the secant of theta. Well, now I can go do my substitution. I replace x with 2 secant theta. So instead of x times x, I've got 2 secant theta times 2 secant theta. 2 times 2, of course, becomes 4. Secant theta times secant theta is secant squared theta. Factor out the 4. Of course, secant squared theta minus 1. You should probably be able to make a guess at what that's going to be. If not, remember that secant squared theta can be traded for 1 plus tangent squared theta. The positive 1 and the negative 1 will cancel out. Leaves me tangent squared theta. Square root of 4, of course, will just be 2. Square root of tangent squared theta will just be 2 times tangent theta. Right? It's kind of like you're just putting your pieces together. You might have a bright idea, right? The good old light bulb over the head. But when you're first starting out, you don't know where every piece has to go. That's what makes it so challenging and fun. Since IXL really just kind of reviews some of the foundational basic skills and doesn't really build upon them, you'll notice that it's been a while since we've been doing much IXL, and it's going to stay worksheets for a while because we're up above just the basic skills. We're not doing basic practice at the moment. It's all more in depth. So it's a worksheet again.